Welcome to the first video from the Cupertino Robotics Project CNC. The purpose of these videos is to give you familiarity, not necessarily competence, in the use of computer-aided design, computer-aided manufacturing, and then actually using the computer-aided manufacturing output to control a CNC mill. Each one of these videos are self-contained and they build on one another. So please attempt to understand a video before you go on to the next video. You'll find the videos will review things that from earlier videos, but they are certainly not standalone. Before we get into the videos, I want to do something that's very important and to thank the people that made this possible. The first I'd like to thank is the Gene Haas Foundation, and they gave us a grant through the first robotics competition, the FRC program, to help fund training for students in CNC and also CAD and CAM. Really appreciate their help. The second group is a group that's helped us for many years, supported our efforts, and this is the Fremont Union High School Foundation. And the foundation provides us funds to acquire the CNC machine and also the equipment that surrounds it to make it easy and safe to use. The next one is the Tormach Corporation, and we're using a Tormach 770M CNC machine, and Tormach provided us strong support and also financial support in getting this machine. Another group we want to thank is Dassault Systems Solidworks. We will use SolidWorks, or do use SolidWorks, to provide the computer-aided design and the computer-aided manufacturing for this machine. We want to thank a couple of mentors. The first is Doug Lowe for his support and initiative in getting the automatic tool changer for the machine. Makes it much easier to build complex parts. And then also we wish to thank Dave Eisand. He's a machinist extraordinaire who made the tool holders, custom tool holders for us, so we could make it much easier for the students to control the tool crib, okay, which is a very important part of the machine. So we have 6 presentations now, and hopefully more later. And we start simple, and then we go up to more complexity. We start with a simple hole through a block. Then we put a slot with the hole. We add a slot, so we have a hole feature and a slot feature in the parlance of CAM. Then we talk computer-aided manufacturing. Then we talk about high-speed milling, which is an incredibly important point, especially when we're using aluminum. We'll next build a simple plate out of a flat sheet, okay, and then we'll add some features to that plate as we build on complexity. Our last example we use is we're going to have a slot on one side of a block and then a pillar on the opposite side of the block to show you how we can use the CNC mill to build 2-sided things, and of course you could extend that to 6-sided things if you wish. Now, it's very important to understand that viewing these videos will help you understand the use of CAD and CAM and how to use the machine, but it will not, and I repeat, will not make you competent in using these. So you expect to familiarize yourself by studying these videos, but in order to operate the CNC mill, you must have close supervision of a trained adult mentor. Failure to not have an adult mentor there will have the following consequences. One is that you'll violate the gracious professionalism rules that we have in the lab, and you don't want to do that. Secondly is you could damage the mill, and with small errors you can do thousands of dollars of damage to that mill. And thirdly, and the most important, is you can seriously hurt yourself or some other student in the lab. So close supervision of a trained adult mentor before you ever try putting something on that mill. The simple hole, we're going to drill a 1/4 inch. And by the way, a machinist will say it's a 250 thousandths hole, okay, rather than using inches and fractions. And we're going to put a 250 thousandths hole in the center of a high density polyethylene block. In doing so, you're going to watch how to use Solidworks CAD to make the 3D model of the hole. Use Solidworks CAM to create the numerical control code to run the mill. And then finally, we'll move that code over to the Tormach 77 or 770 mill, and we'll actually create the part, which is no more than just drilling a hole into this block. So stay with us. It'll take about 20 minutes, and you'll see a lot of stuff. Some of it may make perfect sense to you. Congratulations. Some you may have questions about, and those questions can be asked either through any trained mentor or, more importantly, just looking at another one of these subsequent videos where we go over this stuff again and again, and hopefully it comes true to you. So let's see how to design this part first. This is a very simple example of using SolidWorks and SolidWorks CAM, computer-aided manufacturing, to show how a CAD program and a computer-aided manufacturing or CAM program can create the control G code for our Tormach 770M CNC. So I'm using SolidWorks because it has its integrated CAM with it, and that integrated CAM was also integrated with the 770 before we bought it. So let's go through and make a real simple part, and we'll go from there. So I'm going to make a simple part, and so this is using SolidWorks, but you don't have to be an expert in SolidWorks to know how to do this. So I'm going to make a block, okay, and let's make it, let's say a 2 by 2 inch block, and I'm going to make it 1/2 an inch thick. So let's go in here, let's go sketch, and we'll go up and do a little sketch. I'll do the top plane. This is what I generally do. It turns out that if I did it a little bit differently, it'll make it simpler to do the cam, but I just like doing this way. So we go here. I'm going to get a rectangle for the bottom of this block, and the rectangle is going to be 2 inches. By 2 inches. Okay, we need to get this to be 1/2 an inch. So I'm going to look at my features with SolidWorks, and I'm going to extrude it. And I'm going to go down here, and I'm going to make it 1/2 an inch. So there's my block sitting right there. Okay, it's sitting there. So now what I want to do is I want to put a hole in the block. Okay, and so this is a 2 by 2 inch block, and so I'm going to put a hole right in the middle. So I'm going to pick up another sketch, and right here, and I'm going to put it on the face, and then I'm going to make a little hole, and I'm going to make this hole, whoops, I'll make the hole 1/4 an inch. So I'll go back here to the sketch. So we have that. So I'm going to do a smart dimension on that hole, and I'm going to do a 1/4 an inch. So I have a little hole there, and then I better make that hole a hole. So I'm going to go back into features, and I'm going to do an extruded cut, and I'm going to make it all the way. So I'm going through all, and then got it. Okay, so that's basically what I want to build. I'm going to assume, so I'm going to now, so I finished the CAD. So now I'm going to go into the SolidWorks CAM. And I do two things. I want to pick up the features for SolidWorks CAM, so I use this button up here. And then I want to make sure that I show the tree for SolidWorks CAM. And so I'm going to go over here and I'm going to pick up the tree off of here. So basically this is SolidWorks CAM for me. Now, I need to do a bunch of steps. So let's go through the steps and we'll do them one at a time. The first thing, I have to define the machine that I'm going to be using for this. So I do a double click here for define machine, and this machine is a 4-inch, is a mill, and it's in inches. So that's our machine here. I now need to find out what tools are available for this machine. So I go here and notice that the tool crib is empty. And so I could add tools, but you're not going to do that in this machine. This machine has a fixed tool crib so that we have a consistency across the lab. So if we go down here, see where it says Cupertino Robotics 2, and it's in inches, that's our crib. And so we do that, and now we select it. And so we have a bunch of drills in our crib that we can use, and up here we have a bunch of end mills that we can use, okay, on these. Now, one thing I do not want the CAM software to do, because the CAM software tries to help you in every way possible, do not let it put another tool in this tool crib, because we physically do not have another tool to put in the crib. So see this checkbox right here, make sure you check it, and it says use tools crib only. If you do not check that box, you will contaminate the tool crib, and that will make everybody who uses it pretty unhappy. So we have the tool crib. Now we want to look at the post processor. The post processor is the magic piece of glue that sits between the beginning of the CAM process and the generation of the G code for the 770. So it's a very it's specific to the 770. So I'm going to click on it, and immediately I think I have a problem, because look what it did. It says I don't have a post processor. So I'm going to say that's okay, because I want to find a post processor. You have one and only one post processor in this in our lab. So we take this as the post processor, and we're going to select it. And so that's the post processor for the Tormach mill, and PathPilot is the software that runs that mill. So we have that one there. Postings, setup, rotary axis, and tilt axis are things we don't use. So let's just say we're okay. Okay, so now I want to find out from our stock manager what's going on. So I'm going to go to the stock manager, and I'm going to say, what is this thing that I'm making? Okay, what's the original block I'm going to make this out of? And guess what? I'm going to assume it's a 2x2 block, so this is okay. We're going to do it that way. But it says up here that it's made out of aluminum, and I'm going to switch it to high density polyethylene, because it's cheaper to run. Okay, so I have high density polyethylene here. So I'm done with the stock manager. Then I want to go to the coordinate system, and I need to find out what my coordinates are. And you say, but your coordinates are right there. See the X, Y, and Z. But that's not true, because I can't use that coordinate system with our particular mill. The mill that we have is set up that X, positive X, is to the right, but Y, positive Y, is away from me, not pointing up, and positive Z is pointing up. So I need to change this. The other convention that I use is I always put this axis right here, or the 0, 0 up here in this corner. It just is easy for me. So what I'm going to do is I'm going to say the origin. I'm going to do it by one of the vertices on the stock. And so I'm going to click here, and there are places I can put the origin. So I'm going to put the origin right up here. So notice that's where the origin is. I still have a problem, though, because I still have the Y and the Z flipped on this. So I'm going to go to Y and down over here, and I'm going to select Y, and I'm just going to click, and I said I want Y to be on along this particular, I'm sorry, along this particular axis, right along here, or this particular edge. So I click Y, and Y is over there. So if I peek around, I can see that I have X along this, I have Y along this, but positive Y is to me, and Z is, positive Z is down rather than up. So I need to flip Y so it's pointing away from me. And fortunately, I can do that right here by just going into this and click it up. Okay, so this is a, if I put my block in the mill, this is a great way of, this will be lining up with the conventions of the mill. So I have my, I have my, the coordinate system. Coordinate system here, got the stock manager. Now I need to do a setup. And so I click here, I do mill setup, and then it says the mill is assuming that the front plane is in the, see where it says front plane? The front plane is in the, is parallel to the horizontal surface of the mill. And that's not the way I want to put the, into the mill. I want to put it into a vise so that this is the right is how the mill is going to set up. So this blue area now, the front of this, is going to be parallel to the horizontal surface of the mill. And so when I have a tool go into this particular block, that tool will go straight down into it, which is what I need to drill this hole. So I think that's a good one there. Okay, now I think I'm all set up. Okay, so now I'm going to tell it to look at my design and extract any features that it can help me machine. By the way, not all features of a design can be extracted, but in this case, I think we'll find it does. Okay, so it extracted one feature, and that one feature is this hole. Okay, and you see when I hover onto the hole, what happens is that this hole lights up. So let me go back here. I'm going to go into hover on the hole, and it shows me what it's going to drill. It's going to drill through there. Okay, and it shows me it's going to use a drill for doing this. So that looks pretty good. I'm going to generate an operation plan on this. And so the operation plan says it is going to use tool 45, which is a 1/4 inch drill. And so that's great. Now, if I were to make this hole a different size, for example, if I said, well, I don't want a 1/4 inch, let's say a 250 thousandths, but I want a 260 thousandths hole. Well, this mill can't do that using that drill bit. So we have to make sure that we understand what tools are available and set our hole sizes to match those tools as much as we can. So the drill, it looks like it's there. So we have a drill. Now I'm going to generate a drill path or a tool path on this. So I'm going to go here, click on it, and I have a drill, I have a tool path. So now it says it's basically done everything it wants to do. So let's simulate the tool path. So I'm going to pull up, let me move this over a wee bit. Okay. Okay. And now I'm going to simulate. I'm going to run over here, I have the tool path. I'm going to simulate here. And this is the device. So this is the speed of simulation. I want to slow it down because this is going to happen really fast. Okay, I'm going to then simply simulate it. And there it simulated it. So what did we see? We see a quarter-inch drill bit go bonk right into it. Okay, we can look up here and see that quarter-inch drill bit go through it again. Okay, so that's how it's going to drill this hole. So that looks good. And we can also step through a tool path, but the tool path is simple. It's just boring into the hole. And then we could do a post-processor on this. So I'm going to do a post-process. And it wants me to tell you what this thing is. How about this is a simple hole. And I'll say quarter-inch. Okay, and so I'm going to say, oh, it doesn't like, I forgot I'm in Windows machine. Terrible. Okay, so I'm going to go here. Let me get out of here. 0.25. Okay, so now what it's going to do is going to generate the G code, or it says numeric control code. And so I'm going to push this button to have it generate the code, and there's the code. Okay, so it's only 400 bytes long, so it's a really small piece of code. So let's say that we're done with it, and then we will bring it up. So here's the G code. We're not going to become G code wizards, okay? So I don't expect you to do any G code. So what I'm going to do is this is just a simple, this is what this is called, the file, okay? It's going to take 14 seconds for it to run on the mill, and its stock is high density polyethylene, and it's using a tool which is T45, which is that quarter-inch drill. Okay, this is a whole bunch of things with G stuff to set it up. Let's not worry about this. And then it's going to say we're gonna do this hole. So what we're going to do is you see these G zeros and all of this stuff. We're just going to get it. That's where this hole's going to be located, and then we're just going to plunge that hole, and then we're done. Okay, so it's pretty simple there. So so I'll close this, and then in closing, this is a very, very simple example, but we'll talk about some more involved examples later on. Hope you found this interesting. Bye-bye. We've moved the CNC code over to the Path Pilot controller, and you can see the CNC code sitting right up there in that window. And notice it says that we need tool T45, which is a quarter-inch drill. And so we're going to learn how to put that drill in there before we actually try running it. This is the rest of the code, and so it's really small. So it's just drilling a simple hole, so we'd expect it to be small. So now we're going to see, currently the Path Pilot thinks that there's no tool in there, so we see T is 0. So in order for us to finish this task, we need to get the quarter-inch drill in the spindle of the CNC mill, and we'll see how to do that. Let's do the cycle start. We'll start the program, and since we need to insert T45, we look over here, and it says put T45, and I just put in there drill 250, which is the quarter-inch, or 250 thousandths, which is the quarter-inch drill. So put it into the spindle. So now we're going to have to run over to the tool crib, and it's sitting right to the left, directly to the left of the machine, and we're going to pick up the proper tool. And so let's check it and make sure that it is T45 and it's the 250 thousandths drill. So we have it right there. We're going to run over here and we're going to insert it in the spindle. And in order to do that, we need to press, I'll use my left hand to press a little button on the left side of the ATC, opens the spindle. I'll put it up into the tool into the spindle. I'll give it a little shake to make sure that it actually grabbed it. And then we've loaded the tool onto the CNC mill. So we're going to run back over to see what we have here. Notice PathPilot does not know that we have that tool in yet. We're going to have to press cycle start again to tell it that we've loaded the tool and we're ready to run. So we'll press it. Notice we have T45, and lo and behold, the Z is moving, which means that the machine is actually doing the milling. Let's go take a look at it. This is the polyethylene block and the split vise, and we're getting ready to drill. Notice the Z-axis is going down, and we're using the T45 tool to peck into a hole. And it's as simple as that, and we are done.